Hello everybody. This is the notes for section 1.2 for geometry class. So just a couple words about this idea of watching your notes at home. You got a pause button. Use it. So when you're taking notes and you want to copy something down, just hit pause. It shuts me up. So you can just concentrate on copying this stuff down into your notes, looking at what the picture's saying, looking at the words, trying to make a connection on your own. But then when you hit play, now you can just kind of pay attention to what I'm saying, the explanation of some things, some other little details. So use the pause button to your advantage, all right? And as we move along here in this first couple videos, I'll keep on reminding you, go ahead, hit pause, copy this stuff down, hit pause, try this example. So use that idea to your advantage. All right, so for section 1.2, segments and congruence. First thing we're going to talk about is this idea of a postulate. Okay, it says it's a rule that is accepted without proof. So basically it means it's kind of like common sense. It's an idea that it has to be true. There's no other way around it. It's just got to be true. Okay, axiom, same definition. So this first idea, go ahead, hit pause. If you need to copy this stuff down, you definitely need this in your notes. So go ahead, hit pause, copy down that picture, the little formula there, and then I'll come back. All right, so you've got this copied down here. What we're talking about is the distance between 2 points. So essentially the length of a segment. Now, there is a little bit of notation, it's kind of hidden in here, but this right here. The distance between 2 points, okay? So the length of a segment. You know, when we name a segment, we write it. 2 endpoints with a dash above it. But when we're talking about length, we just use the endpoints, no dash above it. So now we were referring to a length, so we would say segment AB has a length of, and then put a number, whatever its length is. All right, so to get a length for a segment, we're going to use this formula. So basically what we're doing is just putting a ruler between 2 points. So I have a ruler down here. I'll put a point as close as I can to 2, and we'll put a point over here at 7. All right, so here's my point A. Here is my point B. Now, I think it's pretty clear, distance between A and B. If A is at 2, B is at 7, distance is 5. But that's what this formula is just telling us. The length of AB, you just take the difference of those two coordinates. So 2 minus 7. Now, 2 minus 7 is a negative 5. But when we are talking about length of a segment, length of anything, really, the distance between anything, we never talk about negative length, okay? It just doesn't make sense. You know, if you're driving down to Ann Arbor, it's south of here, you don't say Ann Arbor is a negative 30 miles away. It doesn't make any sense. We just say it's 30 miles away. So any distance, any length, it's always a positive number. So what we're going to do is put absolute values around this. Absolute value of negative 5 is 5. So all we're doing to find the distance between 2 points is just taking the difference of the coordinates. Okay? Now, this top part right here, it says when 3 points are collinear, you can say that 1 point is between the other 2. That seems very trivial. It seems like a no-brainer. But what that term between is giving us is it's saying that these points are on the same line. Okay, so it's talking about being collinear, but it's a nicer way to say it. All right, so this postulate, go ahead, hit pause. You need basically everything in this blue box. Okay, the segment addition postulate. Hit pause, please put this into your notes. Very important, we've been talking about it a long time. So, you have this in your notes. So now what we're looking at, it says, if B is between A and C, which, looking at the picture, they're on the same line. Clearly, B is between points A and C. Then, and this is the biggest part of this, AB plus BC. So those two smaller segments, they add up to give us the larger segment. Okay, and just as a simple example, if I told you that the length of AB is 5 and the length of BC is 4, because B is on the same line as A and C, you add up 5 and 4, you get 9, okay? Clear as day. Of course, that's what it is. It has to be that way. But the key thing, again, is this idea of between. They're all on the same line. This postulate does not work if they're not on the same line. So now, looking at this bottom example, you can look at the picture. It's clear B is on line AC, so B is between points A and C. So we can use this segment addition postulate. AB plus BC equals the whole thing, AC. Now that we have this general equation, plug in what we know. AB, that's what we don't know. So I'm going to make that X. Plus BC is 17. That equals AC, which is 42. So X plus 17 equals 42. Our question is, what is AB? Well, AB and X are one and the same, so we need to know what X is. So it's just a simple equation to solve for X. 42 minus 17, 25. So the length of AB, it is 25. Now notice, I did not put the dash above it. That's referring to the length of that segment. Okay. That's your segment addition postulate. It's pretty basic. It does get a little bit more complicated, but that's the idea of it. So now, this next term, congruent segments. Okay, when we say congruent, it basically means equal. But congruent is the subtle difference between congruent and equal. When we're talking about equal, it's a known number, okay? The length of segment AB is 25. So if we had another segment that's 25, we know their lengths, we can say they are equal to each other. When we talk about congruent, it still means they're equal to each other, that means they're the same, but we don't know a length. And so we use this notation here. Okay, I'm going to make it a little bit bigger. AB, the segment AB is congruent. So it's an equal sign with a squiggly above it. Segment AB is congruent to segment CD. So we're naming the segment, we're using the proper notation. We don't really know any lengths, but we do know these two segments are the same. Now the other key thing happens here. When you are looking at pictures, okay, instead of in words saying AB, segment AB is congruent to segment CD, a lot of times it's just easier to put that information into the picture. And that's what these little tick marks are doing, okay? When you see those tick marks in a picture, it means those two segments are congruent to each other. All right, let me just draw a rectangle. Okay, in a rectangle, you should know that the opposite sides are congruent. So that side is congruent to that side. That's what our tick marks are telling us. But we also have the other opposite sides, this top side and this bottom side. They're congruent to each other. Now, in a rectangle, they're usually different than the other two. So I'm going to put two tick marks. All it's doing is just saying the top side and bottom side are congruent to each other, but they are different from the left and right sides. However, the left and right sides are equal to each other because they have that single tick mark. So you're just looking for matching tick marks. That's telling us in the picture those segments are congruent to each other. All right, what I would like you to do is take a second, hit pause, try this problem. Okay, on your notes, just draw a generic X and Y axes, plot these points. I want to know, are these two segments congruent? Okay. Now that you've got that example, I'll tell you what we're going to do is you got it on your notes, you've tried it, we're going to talk about it in class. I want you to do the same thing for this example. Copy the picture down, copy down your given information, give it a try. We'll talk about this in class. We'll do these two examples first thing in class, kind of talk about how the lesson went, what you thought about the video, that kind of stuff. But try these last two examples and have a great night. I'll see you in class tomorrow.